Right. The virtualization server environment, a virtual server environment. Cisco has provided a solution uh, to really go deep into the depthness of the topology, which was not there before when VMware provided the virtualization for servers. So Cisco, along with VMware, has provided a better solution to see the network much more deeper than what VMware was showing. Now, what was the problem with VMware? The problem with VMware was like we were not able to see the devices behind virtualization. Meaning, Cisco provided some virtual box, VMs, 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 and this host has got one NIC card, and this NIC card is connected to a traditional switch, physical switch. Now, whatever we configure on this port, that is the configuration for all these VMs. If I want to do some special configuration for this VM, it was not possible before. It was not possible. If I want to have a special QoS or a special VLAN for this traffic coming from this VM server, that was not possible. There is no visibility behind this NIC card. There was no visibility. So this is a virtual switch through VMware, and this was independent of this network. So this virtual network and this physical network they were not together working. They were separate. This network admin has no visibility to this inside host. There was the problem with VMware solution, VMware switch. So VMware were not supporting by providing visibility till that VM machines. The visibility for the network admin was only up to that NIC card. 1000 comes as a solution to provide visibility till deep into that VM level. Now, before we get into that core understanding, let's quickly go through a few things which we already saw. Like in data center, access layer has got an approach like this. We have something called end of rack and top of rack. Access layers we have in these two different design, end of rack and top of rack. Now, what is the top of rack? We have all the servers, C series or B series servers connected to extender, fabric extender connected to 2K fabric extender. So all the servers are connected to a fabric extender. This may be a B series blade server or a C series chassis based server. They are connected to this 2K, and we have redundant box, 2 box for the failover solution. Now, the advantage of this is we don't run cables between racks because we have top of rack solution. We connect all the servers to this extender, fabric extender. Likewise, there will be another rack similar to this, another rack similar to this. All will have top of rack, and only when we try to communicate to the next level, aggregation layer, we have 5K, where we just take two wires The reason why I have two wires, there are two 5Ks for redundant. So few wires, few cross rack cables, not much. That's the advantage of having a top of rack. So low cable cost, because we run few wires between the racks, nice and decent. The end of rack is like this. Okay, one more thing here about top of rack. Though it minimizes the cabling complexity, but it adds management complexity and power and cooling cost. Why? We have additional two box, so management complexity is increased, additional power and additional cooling system needed. So that's one side of that's the other side of top of rack. End of rack, less cool, less power needed. We got just two boxes in the aggregation layer. Low capital expenditure, less operational expenditure. It is simplified, so nice. So software takes care of all the redundant stuff and so on. All quality of service, security related, multicast related and so on are done here for all the traffic that is coming from top of rack. So end of rack and top of rack. Now in this end of rack, what we have is we have a low cooling system, means not much cooling needed, less power and so on. So there is an advantage. So somehow the problem here is solved here when they work together. This talks about the traditional network, the traditional data center configuration. So anything that you want to configure for this server, you do it on this physical interface. It's for that server. Any configuration that you do here, it's for this server. Anything that I do here for this server. So it is like one to one. One port is connected to one server in the traditional design. So one physical node or server is tied to one switch port. So each port maintains its own statistics, all quality of service or any port profile needed. It's done on the port because it is one to one. So if I need to if I don't want a particular server to be in a network, it is misbehaving, it's not like expected, simply what I do is I go and shut down that physical port. Because it is one to one, we can do this. So troubleshooting was like, one to one, straightforward. So if this is not working, it's malfunctioning, then I can just go and shut down that. Now, so we remove our port security in layer 2. When a port sends more than one MAC address, it shuts down by default when port security is enabled. So it was like one to one. It was easy to troubleshoot. We can quickly identify the server that is getting compromised because of attacks, and we can just lock down very easily. But now we are discussing about virtualization. Anyway, we'll come to that virtualization. Before, let's finish a few more things on standard application. Now here, this is the old story on standard application architecture. There will be a dedicated physical hosts, servers, running a separate operating system on each, and running an application on each. So this may, a good example is Active Directory. Active Directory runs on this host, and this one, let's say, email server works on this. So there's an independent box for each application. There's an independent box for each operating system as well. So this was the design before. But now when virtualization comes, this is basic virtualization. It explains there are many operating systems, 1, 2, 3, 4 in this diagram, and there are 4 applications and 4 operating systems working on a single box. The previous one is separate box, single box. So when we have this, there is advantage as well as disadvantage. The disadvantage has to be solved, has to be resolved. Some solution has to be given to overcome those disadvantages. VMware environment allows multiple operating systems to be installed on the single physical server. With the help of VMware, we can have multiple operating system device installed. This method of server consolidation provides reduced cost and increased utilization. That's totally true. When we have a separate host for each application, we are not fully utilizing the resource. Whereas here we have maximum increase of we have increased utilization plus reduced cost. Cost is reduced. So that is the advantage of having virtualization. Single physical server, having all this VMs as a guest. These all are guest operating systems for this hardware, because there is another base operating system called ESX or ESXi, acting as the main operating system. So these are all guest, VMs are guest. Now virtualized network, entire virtual networks are created behind the physical server. This is what I was explaining sometime before in the beginning of this class. Entire virtual networks are created behind physical server. That's the problem. So in between the physical network, let's say this is the physical network, and here is a virtual network. In between comes the physical hardware box host. So this physical network has no visibility to this VM network. The virtual networks are created behind the physical server. This virtual network is outside of the typical network control used by the access layer. So we got here the access layer where we have physical switches connected to this host. So it's behind it, it's out of control. VM networks were out of control, cannot be controlled by this network engineers or network admin here. This is configured and controlled separately by a system admin. He is also not comfortable with this network configuration. That was a problem. Network admin couldn't get inside and do any sort of VM network related configuration, and system admin has less information about configuring a network, so he's also in trouble. This was the problem. All VMs running on a single physical server shares the physical switch port for a network access. So all the VMs were sharing this single physical port. So anything that I configure on this physical port The impact is for all VMs that is on this host. There cannot be any special treatment for a single single VM. I cannot put them in different VMs. So later solution came via ES6 via the VMware. VMware provided a virtual switch, a vSwitch, where you can keep these guys in different VLAN. But the problem is, again, they are not controlled by the physical network team. Isolated. The virtual network and physical network were totally isolated. They were separated by this host, server, physical server. Anything behind the physical server is not visible to the anything behind the physical server is not visible for the typical network, the physical network. So multiple VMs running on a server connects through the same physical port. So this is one host having this 4 machines, VM machines, one physical host having 4 VMs connected to a single port on the switch. Physical port configuration affects all the attached VMs instead of single server. So any configuration that I make here, it is going to affect all the servers on the VMs, not a single one, it's all. Port configuration is static and not transportable with VM. You will understand that this one in few minutes, when we talk about VMotion. They are static, meaning if I connect this server to this interface and say this interface is in VLAN 10, when I take this connection out from here and connect it to here, I'm no more a VLAN 10 member. I belong to VLAN to which this port belong to. When I unplug from here and plug it here, I lose the membership, VLAN membership. I join the other membership. Maybe you need to manually go here and statically configure VLAN 10. Whereas when we have VMotion or when we have 1000V, when I move the PC, when I move the virtual machine, not the physical machine, when I move the virtual machine, the VLANs, quality of service, everything is moved along with the VM. That's what VMotion. All the port profile goes along with the VM machine. Even if I move the VM to another physical box, still those port profiles are maintained. Now a detailed study we will do, yes. Now any switch, any switch, 1 minute, any switch, if I have a physical connection like this is a physical switch. If I have a physical connection like this, whatever I configure here is for all these machines. Now, when I move one of this VM, let's say to this host, I'm moving this here. I'm taking that file from here and moving it here. This file, this VM is no more a member of, let's say, VLAN 10. This is no more a member of VLAN 10. When I move to this server, whatever this server belong to, let's say this belong to default VLAN 1. Now this VM becomes a member of VLAN 1. So if you want it to be in VLAN 10, again you need to go manually and make this port as VLAN 10. Only then the VM that you copy to this machine becomes a member of VLAN 10. This is not going to be, if we have a virtual switch here using 1000V, when I move a VM machine from one host to the other host, because I can see with the 1000V, because I can see deep down to this VM level, whatever I configured for that VM, it is carried along with the VM when I switch from one host to the other host. They're carried as a profile, port profile. Does that make sense, sir? Yeah, see, VMotion is there in VMware. We have in VMware, but Cisco Nexus 1000 V also provides the same VMware VMotion solution. We call it as distributed. It's coming anyway. Today's class itself covers that one. It is VD. 1 minute. Okay, DRS. It is distributed resource scheduler. Distributed resource scheduler. Yeah. No, we will understand what is VMotion, but we are not into VMware. But equivalent of it we will see in Cisco. No, that's a part of VMware, but the equivalent of VMotion is there in Cisco Nexus 1000V. That we will discuss. Right. So the virtual server environment is like this in the traditional, in the old one. When troubleshooting a network issues, the network administrator team has no visibility into the virtual server level. This still, this is not after 1000V or this is before 1000V. The story is the network admin can see only up to this level. He cannot see this level. This is virtual switch. This is a V switch. It's a V switch provided by VMware. He has no visibility to this one. This one who maintains? System admin. Who is here? Network admin. Network admin has no visibility to this. So troubleshooting is an issue. Internal vSwitch and underlying VMs are hidden from the physical network. So a compromised virtual server will only be traced as far as the physical port, and further diagnostic need to occur that should be taken care by the system admin. So the physical network visibility is only up to this level. Behind this box, this place are totally black for the network admin. Now if there is some server malfunctioning, as a network admin I can shut down this entire VMs. All VMs will go off. I cannot shut down one particular VM. So that can be only turned off by the admin group here. He goes and switches off the VM. As a network team I cannot do that because there is no visibility. So network visibility, physical network, yes, I can as a network team I can see individual server. I can see only the physical server. The virtual network I cannot see. The VMs I cannot see. Port configuration as an individual server. For the physical server I can do. I cannot do for VM machines independently, individually. Network configuration, the physical network administrator do, whereas for a virtual network it is taken care by the VM as well as the network administrator team. Both should work together. Even the network administrator as well as VM team need to work together to have a network over virtual network, network configuration over the virtual network. Security policy, the physical network, it is for the entire server. It is not for a specific VM, a physical server. So virtual server environment requires a new set of network policies and configuration practices, and may involve loss of security guarantees, granularities at security level. Because we cannot see VM level, we cannot provide security to the deep level. We can just give security only to that individual physical server level. So there is no granular security measures taken when we don't have a visibility, when a network admin have no visibility to the VM level. So all this we compare and see, so that we can have a better understanding how 1000V comes as a solution for all this problem. So introduction to VM link, virtual network link. Now this virtual network link concept is there in 5000 series, 5500, 5000 series, where we introduce a 5500. We have a 5500, and by using a line card, by using a fabric extender like 2000 series, we can have different profile to which these VMs are binded. But it's a hardware based solution. We need to buy one 5000 series switch to have that VN link. With the help of VN link, what we can do is we can specifically control. We can control these VMs separately. So ESXi VMs, and we have an initiator provided by this 5000. Now here comes a software solution called 1000V. What it does is, see, it sits inside ESXi. Here ESXi is separate, this initiator is separate, whereas here the initiator is inside ESXi. And now it goes more deep into the VM level itself. Just sits on the virtual ports of VM. Virtual ports of VM. Here there is a mediator ESX between this initiator and the VM. Here we don't see some mediator. This 1000V has become part of ESX now. As this software got installed. We call actually this is VEM, Virtual Ethernet Module, VEM. Now all these ports can be given a special treatment. These are all virtual ports. I can go deep into this virtual port and I can configure. That is the simple way of explaining, but it is not like that. I don't really configure this virtual port. I just add that virtual port to a profile, a port profile, which is already created buy this Nexus 1000 V supervisor, VEM, virtual supervisor module, and whichever the ports that join the port profile, they act according to what the profile says. A detailed study is coming anyway. So 1000V also provides policy based VM connectivity, mobility of network security network and security properties. It also provides non-disruptive operational mode. Now what is these three? These three we are going to see one by one now. Now these three is also provided by a hardware solution, a costly solution. This also be provided by a software solution. So first one is the policy based VM connectivity. So VM connectivity, Nexus 1000V defines, it is defined in the network. The policies are defined in the network. With the help of 1000V, the policies are defined in the network. What policy? The policy that this VM should undergo. The policy that this VM should undergo. So those policies are defined in the network and they are applied with the help of vCenter. They are applied with the help of VMware vCenter. And then there is a special identification called UUID. VM tags maintain it. UUID. We'll talk about this, which helps to identify what policy goes with which VM. Now you see this one, this VMware 1, 2, 3, 4, and on the next server box, this is another server box, physical box, I see 5, which means there is a distributed, virtual distributed switch seen here. There are 2 physical servers, 2 physical hosts, but they're all connected to one switch, logical switch, virtual switch. So according to this switch, this is a separate host connected to first port, second port, third port, fourth port, fifth, sixth, seventh, eighth port. One box, it's like one switch physical box, you connect 8 computers. But there are 2 physical box and 8 VM box. So now what happens is the policies are tied to this number. So when I move this VM here, it is not going to go as VM9. It is not going to go as VM9. It goes as VM1. See, the number remains the same. The policy remains the same. That's what VMMotion is. When I move this VM to other hardware, the ID doesn't change. VM1 remains same. When I move, when I take this VM and put it here, it's not going to go as VM9. It's going to go as VM1. And then VM1 has got some policy tied to it with the help of VMware vCenter. So those things are carried along with the VM. That's the beauty. Yes, sir. Yes. Yeah, you can say that 5 key. Yeah. Now, what is the job of this switch? Is that the question, sir? Okay. No, yeah, good question, good question. Sir, this is a computer, this is a host. This is another host, a server machine. It can be a C series or B series or another chassis based big server, anything. Now, let's say this is host 1 and host 2. And we have VMware installed in this, and we have VMware installed in this. And now we install this 1000V. This 1000V has got two modules, VEM and VSM. Virtual Ethernet module, virtual supervisor module. Now this supervisor module can be a box like this outside, but we don't have that here. I'm saying can be. It can be one of this box. It can be one of this VSM. For redundancy, you can have two of this, two VSMs, which is a control and management plane, and the others are the VM missions, VM servers, VEM. So this is one VEM and this is another VEM, Ethernet module. Now these two VMs are put together as one logical switch, virtual switch. Now for the question, the answer for your question, where is this VSM? Where is this 1000V? This 1000V is just a control plane and data plane. It can be inside one virtual machine on a vCenter client. It can be outside on a physical box like 1100 version hardware box. So you can avoid this hardware. You can keep as a virtual machine itself. This VSM can be, if you can install VSM on a VM machine, yes, it can be done. Then you no need additional box. And this, what it does is it helps to control and manage this switch. Only through this VSM we create these policies and we give it to the vCenter now. Now vCenter takes all the configuration that you provided on this virtual machine, which is 1000V, and a vCenter has that policies. If you bind that policy to this vNIC, then this VM takes all those policies like VLAN number, quality of service, and so on. So this is another box. Now if this VMs goes down, I'm not going to lose this 1000V. Why? These VMs are just control and management plane. Already whatever the necessary configuration that you want to configure, you have configured and given to ESX. ESX is now maintaining those policies. Based on the policy, these guys will be keep on working. Now the problem will come only when some new discovery need to be done. That can be done only by VSM. So you need to bring the VSM quickly. Some sort of negotiation from some protocol from external world goes only through VSM. So VSM can be a separate box, can be also one of the virtual machine. VEM is there on each physical server. This is one VEM, this is another VEM, Ethernet module. Nexus puts all this VM together like one switch, distributed switch, virtual distributed switch. So this is like virtual distributed switch. Now this has got V ports. This is connected here, this is connected here, this is connected here. This V ports, distributed ports, but actually they are from two different physical hardware. Now this virtual machine is binded to these policies, not the V Ethernet, not the interface, not the virtual Ethernet. See, we used to configure everything on a physical port when we want to add some policies for a server on the physical network. Now here we don't bind anything to the physical port. We create some policies, some port profiles, and we add to the VM machine that is trying to join our group so that VMotion can be possible. If I move this VMware to this port, cutting from here, all those policies also carried. Does that make sense, sir? You have any more question? Physical hotbox, and the policies never get changed. They don't get changed. So this is policy based. VM connectivity is still there, not only in 5000 hardware solution, it is also there in 1000. Next is the mobility of network, which we were discussing right now, the mobility, VMotion. Yes, sir. Correct. See, the visibility is there. The network admin has the visibility. So what he does is he creates all the necessary policies here for HR, for database, for compliance, for web application. He creates all the necessary policies where? On the VSM. Where is this VSM? Virtual supervisor model. It may be in this VM or it can be outside, but it is tied up with this Nexus 1000V. So he configures everything on this CLI Cisco environment, network NX OS, and he provides to whom? He provides to this ESX. Now ESX in his GUI, when you click on a drop down button, you can see all the policies that you created on the CLI. Whatever you create here, it can be seen under ESX. So when a new VM is added, you just bind it to that one of the policy that is given by VSM. So all that this team, this system admin team or the VM team need to do is, he needs to just take one policy from the drop down menu and add it to the new VM mission that you join. No other job. Everything is taken care by the network admin. He configures everything and provides as a small link. The VM team, he just binds that tag to the VM machine, and VM machine gets all the network related properties. Everything, sir. It is it is same like how you do on a router. You're going to do same like that. Nothing difference. Only one main difference is it's not physical box. You will get same CLI mode, global configuration mode, interface mode, everything same. When we configure that, ESXi can understand all that you configured. ESX will maintain those policies, those profiles. And when the ESXi team, when the VMware team tries to join a VM, according to the policy, they can simply select that policy and bind it to that VM. And that VM machine gets all those necessary policies. Right. Now, this 1000V also provides mobility of network plus security properties. See, here we see VMmotion. See, this diagram shows that from here VM1, VM2, VM3 and VM4 is moved to the other switch. The thing that we need to note is the number is still the same. Because this ID, UUID is same, all the policies are inherited. It's going to be the same. It is not based on V port. It is based on this ID. Those policies matter. That's why VMMotion is possible. If this host has gone down, I can simply move this one dynamically or physically. That's very nice thing. Dynamically or physically, I can move all these files, VM files, from this server to this server, and they start working here without losing any network related policies. Maybe slight downtime, like a soft boot. That's what it is said. A soft booting time. That time will take for you to switch over. When this physical server goes down, this physical server should kickstart this VM standby machines on this server. That's a booting time, VM boot time, soft boot time, not much, and it will be available with all policies which was there in the previous server, physical server. So it not only that, it ensures VM security. What is this VM security? Now this is a switch. Though it may not be a physical, it's 100% a switch, distributed switch. Now I need some security for the traffic that is coming from each VM. I want ACL. I want some firewall. Yeah, it is possible. We can have ASA 1000V installed in it. That is again another software. You have ASA on it now. So we got security through 1000V. Maintains connectivity state. Means when I do VMmotion, everything is carried out, so it maintains. All right. Now before we go to the next one, let me through VMware vCenter API. API means application programming interface. Cisco Nexus 1000V can monitor the VM migration and ensure the policy enforcement as the machines are moved from one physical box to the other physical box. So server policies are applied and enforced as the VM migrates through automatic or through manual process. That's what I was telling before. I was just reading what I told you before. When I move this VMs from one physical box to the other physical box, either manually or automatically, the policies, the security policies are applied and enforced as a VM migrates. This is done because Nexus 1000V can easily monitor all this VM migration that happens. This can monitor it through vCenter, VMware Virtual vCenter API. API means Application Programming Interface. By using that, Nexus 1000V can say this is moving from this physical box to that physical box. So let me take all the security policies, all the other policies, and enforce it. And the third one, as we have in 5000, we also have a non-disruptive operational mode in 1000. Non-disruptive operational mode means what? The network administrator creates the security policies, security profiles, and these policies are applied to the individual VMs by the VM admin. So we, the network administrator, we create all the security policies and profiles, and the VM admin, he applies it. So here now things are happening because two teams work together, understand each other. So here the VM team is not pressurized with network related stuff. Network admin creates all the network related security profiles and just gives to VM team to apply it. So deployment time is reduced because we already pre-configure all the profile and leave it for the VM admin to use. Whenever a new VM mission is added, VM admin need to just tie that profile to the VM. So it reduces the operational load, workload. So we have got a unified network management and operation, and then the VM level visibility we see here. So network benefits: unified network management and operational, improves operational security, enhance VM network features, policy persistence, VM level visibility. For the security, for the server, again improved scalability, VM level visibility, reduced operational workload. How everything is carried out by the network admin team, so the server teams need to just tie it out all the profiles that is needed, so they are not given the task which they cannot understand. We do it and we give them which they can easily bind it. So reduced deployment time, management is also easy. Next, so Cisco Nexus 1000V feature: security and policy enforcement, operational and management, and organizational structure. What it is, let's see one by one. So security and policy enforcement, we can have ACL. If I want to write an ACL for traffic coming from a VM, I can do it. And I can also have a centralized AAA servers, authentication, authorization, and accounting using TechX and Radius. I can also have a private VLAN. What is private VLAN? When we have multiple devices in same subnet, still I can prevent one device accessing the other device. That's what layer 2 segregation means. I can prevent. That is also, all the security aspects are possible. So whatever we do on a normal switch, in a normal physical switch, you can write an ACL. You can authenticate or authorize and do accounting based on TechX and Radius. We can have a private VLAN. So all these things are even possible through 1000V. Next is operational and management. Now this is possible for us to have a in-service software upgrade, meaning as the machine is running we can keep upgrading. It is also possible in 1000V. Single management point for multiple ESXi. So we just control 1000V, all the ESXi clusters. What is ESXi host? Each server is a physical server is a ESX host. Now because they are all clustered with 1000V, single management point for multiple ESXi host, network-wide management integration. So all these devices are in a one cluster. Management is a single point. Automated policy migration, as we already discussed. As I move one VM from one physical host to the other physical host, they are migrated automatically along with the VM. Configuration consistency is there because we configure only on one VSM. The consistency is there for the entire cluster. How many number of hardware hosts I may have, the consistency is there. There is no variation. Network monitoring and accounting is also easy. We have tools to do that, special tools to do this monitoring and accounting. Not only that, we can also monitor and account through this VSM. Organizational structure, like we, as I already said, we can manage through the CLI of Nexus OS. There is also a special application along with the VM called DCNM. DCNM stands for Data Center Network Manager. It's a tool where we can see the entire data center. We just run the tool and we can see the entire data center, and we can go to a particular section of data center like Fabric Connect or UCS, and we can easily manage them. We can easily observe what is going on. So here we see that there is a need for a join work, cooperation needed between VM team and the network team. A joint installation by VM and network team. Cisco Nexus 1000V manages the network switch using Nexus OS CLI and also through DCNM. Sorry, this is not from VM. This is from Cisco itself. DCNM, Data Center Network Manager. It's by Cisco itself. Multiple host managed at a central point using a standard network practice. So though we have multiple physical hosts having multiple VMs, they're all in one cluster now. So we have a centralized point of management for all the network properties. Now, standard VM admin role, meaning before 1000V. Before 1000V, everything was done by the VM admin. Network admin has nothing to do. vSwitch configuration, network admin cannot do anything. Per EXI host, VM team will do it. Port group configuration, network admin has no visibility. Only VM team. Adding a host, vCenter based. Using vCenter, a VM admin do it. Network admin has no visibility. NIC teaming, network admin has no visibility. vCenter based VM creation, nothing. So it was only taken care by VM network admin. And for security, there is no chance of writing any ACL or having a private VLAN, things like that. Or you don't have any software based ASA running for this VM. No security. Now, after having Cisco Nexus 1000V, admin role changes. And here the VM admin in vSwitch configuration, nothing to do. It's taken care by the network admin. Through 1000V we configure the switch. So it starts working as same like a physical network as we configure through CLI, we configure here also. Port group configuration, again VM admin has nothing to do. We create the port group based on policy and we give it to the VM team, they just tie it, that's all. Adding a ESXi host definitely has to be taken care by VM admin. It is just adding a host using vCenter client, VMware vClient. NIC teaming, we have something called port channel optimized. We do the port channeling, that's called NIC teaming. Here it is automated because we do the port channel. VM creation, again it has to be carried by vCenter, VMware client. Security, we provide security and that is binded as a policy to the VMs by the VM team. Visibility, we have a specific VM visibility. This team was already having it. Now we also have visibility to each VMs. Management, we manage through CLI or XML API. As I already said, API stands for application programmable programming interface, or using SNMP, simple network management protocol, or by using a data center network manager. So after by using all this, we can manage, and through vCenter this VM admin can manage through vCenter. So this chapter gave us a good introduction of what 1000V does, the difference between the traditional and 1000V, and how 1000V does those VMmotions, how it enhances the visibility, in what way the VN link technology different from 1000V. VN link provided by 5000 series, it's a hardware based solution. This is a software based solution, 1000V, and so on. Now next chapter is about same 1000V. We are going to continue. Alright, so here it starts same like the previous chapter, but it is not the same. Here we see that there's a separate operating system running for each application on a specific hardware, a physical hardware. This is the standard design. So the benefit is, because we have dedicated missions, if one device fails, we can easily identify, and if one device is malfunctioning, we can simply switch off. easy administration. The drawback is low security utilization. Only 10 to 20 percentage of the machine is utilized properly. High administrative. Why high administrative? Because we have more number of physical boxes now. So environmental cost is also high. So this is the old story. Now the new story is virtualization. We have VMs, we have separate VNICs, virtual hardwares, hard drives, virtual CPUs, and we got hypervisor, which is being pulled from one set of physical device. So this physical device is a physical pool for all these VMs, hardware pool for all these virtual machines. Now the benefit is we don't have many servers to maintain, few physical servers, because we have less number of physical box, less cooling needed, less power needed, less cable, centralized administration. In order to manage these three machines, I need to manage only this. Easy server deployment because it's just a file now. Server is just a file now, VM file. Deploying a physical box is very difficult. We need to install many things. It will take a long time. Here this is just a file, few minutes. But challenge is this lack of administration separation, because these VM machines are running on one physical box. There is no visibility, so lack of administration separation. Shared architecture, so there is a security concern. Lack of VM level LAN and SAN management. So these are the problems that is solved by 1000V. What is VM cluster? Binding all these VMs together as one VM means, these ESXIs are grouped, the servers are grouped so that we can do VMotion. There will be a high availability. What is high availability? Even if this hardware goes down, these VMs will be moved immediately to here. So we have a crash recovery, high availability. Distributed resource scheduler, which is needed for the VMotion and to provide high availability, works here. So these are the benefits of having a cluster. So this explains high availability. As the hardware goes down, all the VMs are moved to the next hardware. High availability. Distributed resource scheduler. Now, when the CPU utilization goes very high, I can just move one of my VM to here, because here the CPU utilization is very less. So kind of load balancing. Distributed resource scheduler. So now after moving one of the VM to the other, balanced. Previously the left hand side was too high, now it is balanced. Now that is possible through VMotion. We move from one to another. When one hardware goes down, we move it, or when the CPU goes up, we move, so that we can do some load balancing. So this mobility, VM mobility is possible when we have a unique ID to identify these boxes. We will understand this when we look into the practical side of this. Because there is a unique ID to identify, they are moved easily. The migration happens. The VMware migration through VMotion or distributed or through the distributed resource scheduler DRS and high availability, the physical switch ports, they are attached. So through the physical port, actually the movement happens like this. The VMotion happens like this. They are connected to one physical port, and they must belong to a common group cluster ID. This is possible. Again, this diagram shows us, the physical NIC, only two physical NIC, and there is a vSwitch inside provided by VMware. There is a VM hypervisor. So virtual NICs are created through ESXi or ESX, and each virtual machine has got a separate virtual NIC through which the switches, this vSwitch takes all the traffic and provides to the physical NIC that is connected to the external switch. So there is two layers, virtual access layer and physical access layer. Physical access layer, we have visibility, but we don't have visibility to the virtual access layer. That's what I explained in the previous chapter as well. So to provide visibility only, we need 1000V. So the previous chapter was overall. It was giving overall understanding of what we are going to see today and tomorrow. Now here, same like a server, even for storage we don't have visibility. Now we have a lot of VM storage, LUNs. So we have visibility only up to this physical FC card, fiber channel card. We do not have visibility till deep into this level. So again, for this also the same solution. Whatever we saw in the previous chapter. So for SAN as well as LAN, we have a solution. This storage device is given to a server here. So whatever you saw for the previous LAN, it's the same story. The visibility is needed. An administrator should see, network admin should see till this level. There should be visibility provided. So our 1000V provides that. So how this VM environment is managed with the help of VMware. VMware vCenter helps us to provide this configuration. We can configure 1000V on a vCenter client. VMware environment consists of physical server running a VM operating machine on it, known as ESXi host. This is an optional one. Optionally, vCenter server can be used to manage multiple hosts, but we can use client itself. vSphere client is a GUI tool that can be used for managing VM ESXi host as well as vCenter server. What is VM host? The physical server on which we have a lot of VM machines. These hosts can be managed using the Linux-based CLI or vSphere GUI client software. So what is vCenter server? vCenter server is also another managing tool. When we have multiple VMware hosts, this tool is to manage. vCenter host can run on a physical machine or can run on a VM machine. vCenter server is required for VMotion, for high availability, and for distributed resource scheduler. vCenter clients are preferred management tool. Then we use server, we use client, vSphere client. This is the preferred one for VMware ESXi server as well as the management of vCenter server. Yes, sir. Server, yeah. We will, yes, we will do it. Definitely we'll use it. Yeah. Yes. Yes. No, we will also use it. Not necessary. Why we need 5000? Not necessary. Just to maintain the cluster, we need 1000. That's all. No need of 5000 at all. No need of 5000. Not necessary, because we got all the management and control plane on 1000 itself. Only when we don't have 1000, we depend on 5000. Only when we don't have 1000 software solution, we depend on hardware solution for control and management. Not necessary at all. Not needed. This is now 100% switch. 1000 V is 100% switch. Whatever a switch can provide, physical switch can provide, this can provide. Then there is no need of another Nexus in between. Yes. Now the vSphere client is a preferred management tool. This is how it will look like. Now, and this vCenter client has these two panels. On the left we see the topology pan, on the right we see the configuration information. There are a lot of tabs actually. We need to click on this to add some VMs, to add some policies, profiles to VM, and many more things. Whenever we configure Nexus 1000 VSM, we will have some change happening here. This is the best place to monitor as well as configure the VMs. So far we have gone through a brief overall view of what we are going to see another three days on 1000 V. We have come to the 50th page of our 1000 V. We have another 170 pages to finish our 1000 V understanding.